So welcome to this talk on data analysis. So data analysis has become a thing in probably the past maybe 5 years. And it also has become a thing for people to study computer science because there is some connection there between data analysis and computer science because you have to write some programs to do data analysis. So what I want to do today is to give you a quick glimpse of what this whole data analysis is. We're going to do that with an example, which is the best I've seen so far, but if somebody comes up with a new example, I'm happy to entertain. So my example today has to do with doors, okay? Everybody has been exposed to a door in your life? You all know what it is? Okay, so I do data analysis, and I also like to think about crazy companies that we should start in the future. And so my impression was that when I was in school, I tended to be the last person in line. And in Uruguay, we line people up based on height. So when I go past the door, one of my feelings is the door is too high. We seem to be losing material by making the door so high. Okay? So I want to create a new company called Marcelo Doors, where we sell shorter doors for the average person. Okay? And the question becomes, how tall is a door for my company? Okay? And now some of you are thinking, well, that is a horrible idea because I'm tall and you're going to make a door that is shorter than me and now I can't go through the door. So I have to give you some bad news. Does anybody know how tall the tallest person is? The tallest person in the world?
7 foot something?
How about 4 or 7 foot something? Yeah.
I really don't know though exactly.
About 8 foot.
No, sorry, how much?
Above 8 foot.
About 8, okay. Do we have anybody who thinks about 9?
I think that's right.
Sorry?
Probably happened.
It probably happened sometime?
Alive or dead?
Alive.
I think he's 8'2" now.
8'2", okay.
Alive or dead.
So that's an interesting distinction. Marcelo Doors build doors for people who are alive, yes. We're still not considering dead people through my doors,
Like
but
you can't do
eventually
any
we
money,
could.
so.
Okay, so I always do this with Google, but given that we're in the neighborhood, we're going to try and use Bing and see if it doesn't. So we're going to Bing tallest person alive. And the tallest person alive
8 foot 2.8 inches.
is 8 foot 2 points. It's right there.
Yeah.
2.8. So wow, that was very cool. Who was the person who knew this? How do you know this?
I saw a video about him recently.
Wow. Okay, so then how tall is this door?
It's like 7 foot. Maybe.
How much?
About 7 foot.
About 7, okay. Do you know, did you get a documentary on doors? No, okay, well, so I will have to go back to the system and say, oh no, okay, wait, okay.
6 feet 8 inches.
6'8". Okay, so what happens if the tallest person in the world wants to go through this door?
He hangs both head and neck on the top.
That would be if the tallest person is not very smart. They can actually do something better, which is a duck, okay? So for those of you who are thinking this is height discrimination, we are already doing this, okay? So if you want to defend the tall people, you have to go back and complain that door needs to be at least 8'3" so far. Because tomorrow somebody may be born who becomes taller, okay? So this has nothing to do with that. We're not trying to do anything to the tall people. We're just trying to optimize our business by allowing some people to bend when they go through the door. Okay? So
It's a funny way of putting it.
this one is an easy one. So if we wanted to support 100% of the people, then 100% of people go through door equals 2.8. Okay? So then the next interesting question becomes, well, how many people are we willing to sacrifice so that they have to bend through the door?
All of them.
All of what you... That would be no door at all. You can't go
Oh,
up.
no, that's not true. You could, I think you could look up the shortest person and then set it an inch shorter.
Okay, well, you will make, yes. Actually, I've never done this, but we could actually try. We can. The shortest person is 21 inches.
Just under 2 feet.
Okay, so you're correct. We could create a door that is 20 inches and everybody has to crawl behind and there is no debate here. We're all equally crawling through the door. Okay? Okay, so now we have two data points that are very easy to find. The maximum and the minimum. That will let me all the people through. Okay? Now has anybody flown, like taking an airline flight? Okay? This is the same calculation they do, right? They say, well, instead of making 100% of the people happy, I know some people don't show up, so I'm going to make 95% of the people happy, and then I'm going to get the other 5% out of the plane. And on average, this average nicely. Okay, so this is something that people do all the time, and usually annoys us, but we live with it. Okay, so then the next decision, which is not a data analysis decision, it's a business decision, is me, the CEO of this company, has to decide how many people I want to get through as a percentage. Okay? So I'm going to delegate my powers to, I guess, to you. Okay. And you're going to, how many people do you think should go through as a percentage?
Probably 90, 95%.
90, 95%. Okay.
Something like that. I feel like
Yeah, you'd probably cut out.
to make a better business decision, you'd probably want to know what your modal human being is. Like what's the most common height?
Oh, that doesn't matter because depending on how high the person is, there is always going to be a 95%.
That's true. Okay.
So again, that's a separation between the business and the data analysis.
I think-
Once you tell me this, I will do the data analysis and tell you how tall the door needs to be.
Gotcha.
But this part, I cannot tell you. Yep, go ahead.
I think another thing you want to look at is how exactly much height are you cutting off before it starts to become before you're cutting off like half an inch and cutting off another 10%.
True, yes. Or before I make the door taller than it is right now, right?
Because like I have a feeling that from like the 100% to like what 90% or something like that.
Yeah.
That could be like
Yeah, exactly.
2 feet.
Correct. So you are a least decisive manager, but that is true. So his point is we need to move this decision later because maybe the difference between like 95 and 100 it's only like half an inch, and it's not worth keeping those people up.
Yeah.
Make sense? Okay. I still prefer the decisive boss. So we're gonna try to look at 90, 95, and then go high. That is an impressively high number, though. I think most people in business would pick like 80% or so.
Really?
And also don't forget that not every business is what most people are going through. So for example, if you run like the Ferrari or the Lamborghini business, how many people actually get access to your service?
Very minimal.
Very minimal, right? Less than 1%. Okay? So also this concept that we want our service to be given to everyone is not always true. There's actually a lot of companies that make a lot of money out of the fact that they don't serve everyone. Okay, so now that we have this, we can actually do the analysis that he was talking about. So we're going to go through the data analysis process, and we're going to try to figure out how tall should my door be so that 90, 95 can go through, and then we'll do his analysis to figure out the differential of letting more people. Okay? Okay, so what is step one then? What is the first thing I need to do? So to do any of this analysis, I'm going to need,
Identify like average heights.
correct, but before I can identify the thing, I need height, okay? And this is height. This is very important, I need to find heights. Okay? And this is, this first step is the thing that has become easier with time, which means data analysis has become more possible, okay? So how do I figure out the heights? What do I need to do?
You need to collect data.
To collect data. So the data is heights, so how do I collect it?
Or find data that's already been collected.
Yes, okay, so that's an option. So I can Google height data, because somebody else probably already did this, and I will recycle their data. Or if I had to do it myself, what kind of process can I use to get this data?
Poll.
I can poll people, yes. People may lie, but I can poll.
A census.
I can do what?
A census.
A census, yes. I can send people to people's houses or do an online poll. Okay? So that we do all the time, but it has a slight tweak, which is, again, people may lie. Some people may feel too tall or too short, and now they give me the wrong number.
It's
So
inaccurate.
how do I get more accuracy?
Manually measure their height.
Okay, that goes to the extreme of the creepiness level, but yes. You put a stamp right there and start like free sodas in exchange for heights, and you measure these people, yeah?
I suppose you could theoretically get people's height from something as simple as a Facebook picture, if it's...
Yes, that is an even more creepy way. You can do some image analysis, take people's pictures from Facebook, find some parameter. For example, I'm standing next to a well-known thing, so we know how much that thing is. So you can find the difference based on where I'm standing, so yes. That would be the extreme of the creepiness.
I mean, I know that there are definitely some businesses that would
Oh,
probably...
Facebook, this is Facebook business model, right? Analyzing what you put in there and trying to figure out what's there. That's exactly Facebook's model. There is an intermediate one, which is I can put sensors in this door. So I can put a measurement thing up there, and every time you go through the door, I will measure your height. And then over time, I'm gonna get enough height data to know the average height to the people going through the door.
That could be incorrect too, though. Like girls who have buns on top of their head
Yeah.
or something, so.
Yes, I need a better sense, yes.
Or the same person might come through and out the door multiple times a day and
Yes.
only get that
Correct,
height
yes.
recorded.
Which means we need to combine your idea with his idea, and instead of measuring directly, we take a picture of the person and make sure we hash it out, we take away the hats, and we get the measurements, yes?
Mug shots.
Yes, those are actually designed to have that, right? So,
Yeah.
yeah, so if you're going for
Lineups,
that,
yeah, I feel like lineups would be better because mugshots, you could say that that's a certain percent of the population that's a very specific percentage.
yes, so,
has
but I can,
skewed.
yes, correct, but I can also decide that Marcelo doors are only for prisons. My best thing over there. But that's a good point, and but your point is better because I don't know how much you know about this, but the lineup has more than one person, so I can get more
The
than one
lineup
data point.
picks random people even. They'll just go and pick random people for lineups
Yes.
too.
And then finally, this is actually taken by your doctor. So if we can get the doctors to give us for free the heights, this is part of your medical record. So if they are willing to anonymize your heights and give it to us, then we will have enough data to do the analysis. Okay? So that is a key thing that has happened that has made data analysis possible, which is data is way more available now than it used to be. Because we have creepier ways to get the data, and all the data is in computers here or there, so it's much easier to aggregate it and to distribute. So none of the systems or the mechanisms we're going to use to do analysis are anything that was invented yesterday, like the mean, the median, the average, standard deviation, the regression analysis. All that has been there forever. The only thing that we have now is more data and faster computers. That's the only difference. Okay, so imagine I have the heights, and I'm gonna go and we don't have enough time to conduct the analysis. My Facebook friend refuses to let me use their pictures for these purposes. So I downloaded some data directly from the internet. So from now on, we're going to assume that this is the height data. There are 10,000 data points in here. Okay? So the first layer of data analysis, somebody is very bored on the internet. More than the person who watches documentaries about the tallest person. Okay, so in here, we have 10,000 data points. So the first layer of data analysis can be done by people who know how to use Excel. Okay? So this causes me a problem because using Excel is not as complicated, so I can't make as much manual as just moving cells in Excel. But I'm going to show you what it is. So here are all the heights and weights, and they're also discriminating this by gender. So what we want to do is we want to find the point that allows 50% of the people to go through. Okay? Does anybody remember from your high school classes how that point is called?
The mean,
It's not the mean.
Median.
Somebody said it correctly?
Median.
The median, correct. Okay? So the median is by definition the point at which 50% of the thing is above and 50% of the thing is below. Okay? Many of you said the mean. That is also true, but only in some cases. Okay? So for now, we don't know if this is one of those cases, so we're going to do the median. Okay? So how do I calculate the median of those heights? Do we have any Excel wizard in here? Yes.
You add them all together and divide them by how many there are.
That's the mean.
Oh, shit.
Yes.
You line them all up and count the middle?
What, did you know this
You
from?
sort by,
Yeah.
that cell, and then you go to cell, I guess, in this case 501.
Yes, correct, yes. Did you know this from before, or did you just make it up?
I know what median is.
Okay, and you know what Excel is and those two together?
My dad works for Excel and Microsoft, so.
Oh, perfect, okay.
Yeah.
So I can't bash Excel, so Excel, the most awesome product. Okay, so I'm gonna use some Excel features just to show off the fact that I used to work on Microsoft and I used to use Excel. So I'm gonna insert a table. I'm gonna sort this by height. And then I told you there are 10,000 rows in here, so which row is the median?
5,000?
I need an Excel expert, you were close but not.
5001,
5,001, why?
because we have one extra cell.
Yeah, because the titles in Excel count as a cell. Okay? So we have to go one extra there. Anybody knows what's the fastest way to go to 5001?
Control G.
Sorry?
Isn't it Control G or something like that?
I have no idea.
The go-to?
Wow. And what do I put in there?
Don't you put in 5001?
I have no idea. This is the first time I pressed Control G.
No? Okay. I can't read it from here.
No, give me an error. Okay, well, I can do it the whole way. It's gonna take a while.
Goodness, maybe.
Overshot.
Okay, this is where we don't use Excel when it comes to many data points. Close enough. There we go. 66.3179. 66.3179 is the height of a door through which 50% of the people can go through without having to bend. Make sense? Okay.
Is that inches?
Yes, because it's hard to represent this stuff.
Okay,
You
yeah,
have to
yeah.
represent it in inches. As I tell people, I may not see it in my lifetime, but eventually the US will come to terms. You will measure this in actual measuring systems. This will be in centimeters, as it should be, should have been forever. But for now, I'm gonna go with inches. So 66.31, okay? And we just did data analysis, okay? No complexity, again, the system to do data analysis is not new. We're just having more data, okay? Now there is another way to do this, which is Excel is nice enough that it has a function called median. Okay? So if I say the median of this column, I should hopefully get the same number. I don't know. I got the number after it, 66.
That might actually be more
Which
accurate.
means I miscounted my data points, or it may be wrong. But,
Marcelo, was that including that header line at line 1?
I think it did not include the header line, yes, so let me do the next one. Fascinating. I think it counted the header one as a 0. Okay, so that is Excel's median, our manual median. They're well, like we're not gonna get to this level of precision in the door, so both of them are pretty reasonable. Okay, so now imagine I want to allow 75% of the people to go through the door. Does anybody know how this mathematical function is called?
weighted average?
No.
What function?
The function that gives you this 25, 50, 75, or 100%. Perfect. How do you know this? You studied math, okay? You're finally confessing, okay. You seem very disappointed this time. I studied math. I was going to ask him how he knows so much about mugshots. And I think he would have told me I was in prison, and he would have been happier than you. He should be excited that you know math. Okay, so that is called, which quartile is this?
Third.
Okay, so quartile is basically we are dividing this in quarters.
Okay.
Okay, so we're dividing in pieces of 1/4 each. So this is called a quartile. And so there is an Excel function called a quartile. And I'm going to put the same values. And then it's asking me the first, second, or third. He knows that is the third, the 75 percentile. Okay, so we're going to pick that one. And the answer is 69.17 from 18. Okay, so this was the 50%, this is the 75%, and now imagine I want to do the 95%. What do I use?
Percentile.
Yes, you know this existed or you just?
I didn't know about quartile, I knew about percentile, I guess it's a subset.
Percentile is a superset of quartile, okay?
Yeah, quartile.
So then we're going to calculate the percentile. Are you seeing the percentile? This is the way you measure test results.
Yeah.
Like if they tell you you are in the top 2 percentile, that means you did well or poorly.
Oh, yeah.
Yeah, you did better than 2% of the people.
Sorry?
You did better than 2% of the
Yes,
people.
which is not good.
No.
Okay?
Wow.
Yes. Okay, so we're going to use that function called percentile. We're going to do B. And now we have to say which percentile. So we're going to hit 95. 72.62. Okay? So 95% of the people, these people, will go through the door if we make it 72.62 inches. Okay? Can anybody translate 6'8" to inches? Because now we have to talk in the same units.
It's 80
Sorry?
inches?
Yes.
80.
80, perfect. Well, that was very fast. Okay, so you can see that our current doors, as used by these people, are actually a little taller than they need to. Okay? Because 95% of the people will go through the door even if we cut 7 inches from that thing. Okay? Again, I was born in a place where we don't use inches, so I have no idea how much 7 inches is. Does anybody want to give me a guess? Like this?
Yeah, it's about right.
Okay, let's see. Yeah, I'm still going through, so good, yes. 7 inches causes that effect, okay? And so we went from this, and then if we wanted to do 100% from that data, which number do we pick?
Just the one at the bottom,
Sorry?
just the number at the bottom.
The number at the bottom, which we can also call the maximum, right? And that would be 79 inches. Okay? So that means that our current doors allow 100% of the people through, and an extra inch just in case. Make sense? Okay, so notice that we did all that analysis without actually having to do any complex statistics. So then you will be wondering, what is complex statistics for? Well, the problem we have is that these people over here, these 10,000 people, do not represent how many people are there in the world. Okay? This is just a sample of the people in the whole world. Correct? So that's where the statistics come in. We need to take a look at the behavior of these variables to see if we can use this to say, well, the rest of the people operate the same way. Okay? So for example, this would be the same as saying, I ask you, all of you, your heights, and then I use that to calculate the door height. It's too few people. The drawing does not represent everyone in the picture. Make sense? Okay, so that's when it gets more interesting. And the first thing we want to do with this data is we want to take a look and see how it distributes. Okay? How it distributes means that we want to see how many people are in the 55, how many people are in the 54, how many people are in the 60 range. Okay, so we're going to look at height and how many people are in those heights. Remember how that is called?
Frequency?
Yes, but the diagram?
Histogram.
Yes, a histogram. Okay, so that's what we care about. We want to draw a histogram. Make sense? Okay, so now that we have to draw something, we're going to move from doing data analysis on Excel with a table to doing graphical data analysis. Okay? And for that, we're going to use the thing the company I work for uses, which is called Tableau. And so this you can think of as Excel, but to make charts faster. Okay? So I'm going to pick, I brought the data to the thing, I'm going to pick the height, and I'm going to draw a histogram. Okay? The reason why people pay us to do this is because it's very easy to click around. Okay? Drag and drop, pick what you want to do, click on the correct thing that is highlighted, and now it's going to give you your histogram. And so what does this look like?
Like a bell curve.
This is the famous bell curve. Okay? So that's what people, that's our favorite picture, because if it's a bell curve, then it has certain properties that we can use to do statistics with it. Okay? So anything that distributes like a bell curve has what we call a normal distribution. Okay? That basically means that most of the values are close to the average, and then there isn't that much spread away from the average, which means the average is a good representative of everything else. Okay? Notice that the tallest person was not in this data set, because if he was there, there would be a point over there. Okay? But so this means that population height does behave normally. Again, that means that most of the values are around the mean, and there isn't a big spread. Yes?
What would happen if it wasn't a bell curve?
Then the data analysis becomes way more complicated. It basically will mean that you need more data points. Okay? But what this tells you is that you actually don't need that many more data points. Okay? Because there aren't that many outliers. So unless your survey is completely biased to one particular place, if you pick the people at random, this means that you did a fairly good job at picking the people at random. Make sense? Yes? Okay, so sadly though, this is not exactly a normal distribution, because as you see, most of the values actually don't accumulate in the middle, they tend to accumulate to the sides of the middle. Correct? This is the part that I should be able to give awards to people. So let's see who is the future data scientist in here. Why do you think that's happening? Why do you think instead of accumulating in the midpoint, they seem to be accumulated in two midpoints, kind of one on each side? Yes? Yes, that's what it is. So what we're going to do is we're going to bring the gender to the equation. And I'm going to color code this based on gender.
Whoa.
And now you see what is happening. Okay? Something that you've known for a long time, which is if orange is males and blue is females, who is taller based on your life experience on average? Sorry?
Most men tend to be
Yes.
taller.
So on average, men tend to be taller. It doesn't mean that if I pick two people randomly here, one male and one female, you're going to be, the male's going to be taller. That's not true. But on average, you have this. Okay, so now these ones are actually, this one in particular is a nice normal distribution. Make sense? So now if you want to separate them, I'm going to move the gender to filters. and I'm going to show only males. Okay, so this is more how the normal distribution looks. It's ideally accumulated in the middle and not too far from the middle. And now if I bring the females, which is this, it also has that shape. Okay? So what this is it shapes some of the variance there on the sides. Okay? Okay, so now we can do, now that we see that this is decently normal, we can do some more fun statistics. So, do you know how the mean point is called? So that mean point is now what people were saying, the mean. Does anybody know the measurement of the spread, like the separation, how that is called? The number that tells you how open this is, do you remember?
Standard deviation.
Yeah, this is the standard deviation, okay? The standard deviation is nothing more than a measurement of, on average, how far a point is from the middle, okay? So if you want a distribution that is the nicest, you are basically looking for small standard deviations. The smaller the standard deviation, the more predictable the behavior is, because it's closer to the mean. Make sense? More for some of you than others? Okay, so now that we solved the door problem, let's solve the height mystery. So the height mystery was, who said this? Who said males are taller than females? Okay. So in data analysis, we're going to call that a hypothesis. Okay? So in terms of means, or the midpoint there, how would you say males are taller than female? If you wanted to say based on the mean of each side.
You just look at the value of the number itself.
Yeah, so the mean for males should be
Higher
than,
than the mean for females.
yeah, exactly, okay? And we're going to call the mean mu just because people call it that way. Okay, and what is the opposite of this? So if that is not true, what is true?
Then the mean for females is greater than the mean for males, or mu.
Yeah, so this is smaller or equal to the mean for females. Okay, make sense? Okay. To make the test simpler, we're going to only test it without this. So we're going to say they're either the same or male is bigger than female. Okay? We could actually test S3, but for now we'll just test those two. Okay? Now this test is very complex to do in Tableau, so we're going to have to do it in the one thing that is actually related to programming. We are going to use R. Okay? Has anybody seen this before? So R is the language that people who do data analysis and for some reason decided not to use another programming language that already existed, invented and are using. Okay? It's called R, it comes in RStudio. It looks like a programming language. It's closer to Python than anything else. And so we're actually going to do just tiny programming. So the first line right there, sorry, the third line right there, serves the purpose of bringing the data. So this is the same file I keep moving around. And so now I'm going to calculate the mean of data heights. Okay, and we know that number is around 63.36. It's a little more than this because this one is adding all of them and dividing it as opposed to just finding the midpoint. Okay? Okay, and so this language is a weird combination of programming languages and SQL. So I'm going to split the data in two, and I'm going to say data for male equals my data filtered by gender equals male.
Oh my.
Okay? This is the part where we actually make math, because this is hard enough that we can actually, not everybody can do. So this is the part that you learn in data analysis classes. Okay? Up to now, you can just move things in Excel. But now this gets complicated. So the data for male. Okay? Again, it's a combination of SQL some C# in there, and a little bit of Python. Okay, so now I'm going to compare that to the data for female, which is going to look the same. Okay, and the other thing is, if you look at what's happening, no error is good. Okay, so if I don't get an error here, then that means that whatever I'm doing is working. So to double check, I'm going to ask for the data for male and see what number comes up. Okay, then I'm going to ask for the data for female and see what number comes up. So this is basically the first row of the data. So I'm getting some information from there. And so now I can do this manually, which means I can say the mean of the data for male for the height, and then the mean of the data for females for the height. And as you can see, just comparing the means, I can tell that this one is higher than this. Okay? Now statistically that is not enough, because whether that is true or not depends on the distribution. If the distribution is not normal, then this number could basically be anything. Okay? So I need the distribution to be normal so that I can actually compare. Okay? And so to officially do this, we have to do a statistical test. It's called the t-test. Okay? Again, don't worry about exactly what it is. This is what they teach you in data analysis. The t-test is a way to compare two means. And what it does is, it compares the value, but it takes into account the distribution and the standard deviation. Okay? Again, you don't need to know much of that, just need to be able to run the thing, which is I want to compare the mean here versus the mean here. Okay? And again, this is the part where we can judge people because it's a little harder to understand what it says. So what this says is, here is the mean that we calculated before, and then if you look at this number right there, it's very small. Okay? So when this number is very small, it means that this is not true. So that's the conversion you have to be able to do in practice. So once you invented what your test is, which is this, and you run it, then you look at this number, it's called a p-value, and if this number is small, then you say this is not true. Okay? Which means this needs to be true because we know the mean for males is higher than the mean for females. So it cannot be the other way. Okay? So now we need a little bit more complex data analysis. Okay? So we came to a hypothesis, that's why this is called hypothesis testing, which was this. We separated the data, that's called data preparation, and then we run a statistical test to make sure that our hypothesis was either true or false. Okay? So that is the whole process of data analysis at the complex level. You invent a hypothesis, you move the data around to test your hypothesis, and then you run the test. Okay? You have to invent a hypothesis that we can test. So we were very fortunate that the hypothesis that you brought up is something we can test. There is no test for every hypothesis, but we have one that wasn't there. Make sense? Yes? Okay? So if this is interesting to you, then you can take a data analysis class and they will explain to you exactly what that is and what kind of magic happens behind the scenes and then how to program this correctly. Okay? Okay, so we're going to move, given that we have the data, to a slightly different issue. Which, if you look at what's happening, I have data on height and weight. Okay? So my data is basically gender, height, weight. Okay? So I'm going to try to design another hypothesis, which is, what do you think is the relationship between height and weight?
Positive,
Positive meaning?
meaning that an increase in height on average, or usually dictates an increase in weight.
Why?
Because as you are a taller person, you become a bigger person. That adds to your mass.
Yeah, because to be taller, you have to have like something physical which has a weight. Okay? So you have, on average, you're going to have more weight. It's just basically the extra body that accounts for the extra inches. Okay? So then, if your thing is true, we're gonna see the relationship. So what I'm gonna do is I'm gonna draw the weight versus the height. So I'm gonna create a thing here called height and weight. Okay? And see what happens. So this is the height, this is the weight. So he theorized that there is a relationship between height and weight, and the taller the person, the more the weight, and this chart seems to agree with you.
Agree with me.
More than you think. There is a scaling issue too. This looks more steep than it actually is,
Oh, okay.
because there is a lot of white space here. Make sense?
Mhm.
So if I move the number to something like 50,
Okay, yeah.
this is how you cheat with charts. You change the scale, and then you can make it as steep as you want, or as flat as you want. So when you watch the news, you can see they do this all the time to prove their point. So, but okay, so this is clearly okay. So now, this again doesn't mean that every person, that if I have two people from here, the taller one will be way more. That's not true. It means that on average, in a big enough population, that statement will be true. Okay? Okay, so from all the geometrical, one-dimension things that you know, what does this look like? What does a relationship look like?
Linear.
Sorry?
It's a linear relationship.
It's a linear relationship, it's a line, correct? Yes? So there are other shapes. It could be something like some curve, some other kind of curve, but this one is pretty clear a line. Yes? Correct? Okay, so now back to our math lovers. If this was a line, and I wanted to write the equation of the weight, which would be the weight equals something that is a function of the height, what would that equation look like? If it was an actual line. Yes, go ahead.
mx plus b.
Yeah, so in this case, mh plus b like this. Okay? So what he says is that there is a number to multiply h, which is basically the slope of the curve, and then there is a point to start, which is where the line intersects the axis.
So
Okay.
a person of height 0 has a weight of, well, theoretical, well, not even that.
So that's a good point, which is, once you project this is actually not a line, right? Because people who weight, like when you're a baby, you don't weight 0, correct?
Oh, no, you don't, your height isn't 0 either, though.
Correct, but so in here, from below 0, sorry, from below 50, is not so much a line, because this is gonna cut before, and it's gonna
Yeah,
suggest
and be like,
that a person of height 1 will have negative weight. Okay?
yeah.
So what that means is that this data doesn't include those people, which means we cannot use it to project. Okay, so we can only use this to calculate the relationship between the people we know. The people that we don't know or haven't measured, we can't do any calculation. Okay? Okay, so this is our hypothesis then, that there is an M and a P such that you can calculate the weight based on the height. Okay? Luckily, that's a very common hypothesis, so there is a direct way to calculate that. So you can calculate in R by saying, I want the relationship between the height, the weight, and the height. And so R will tell you the answer. Okay? But luckily we can also do this visually, so I'm going to do it in Tableau because it looks slightly better. So I'm going to come here and say, give me a trend line. Okay? And so the program did the calculation, and now we have the line. Okay? I'm going to hover over the line to see the answer. And there you have the answer. The weight equals 7.71 the height minus 350. Okay? So then how many more pounds do you get per extra inch of height?
7.71.
7.71, correct? That's what this number means, which is this number. Every extra inch gives you 7 pounds.
That seems like a lot.
Hmm?
That seems like a lot.
That seems like, yes, correct, yes. How much is an inch?
It's about like that, yeah.
Interesting. Okay. So let's try to predict a person. So now imagine you have a person whose height, and this one again I need some help. What is an average height of someone?
6'8", or 5'8", 5'9" is what you're looking
Which
at
in
here.
inches?
68, 69 inches.
68, okay. Okay, so if I have a person whose height is 68, how much is their expected average weight? So you would have to take 68, multiply by 7.7,
7.
and then subtract 350. Okay? So we're gonna quickly do that in the calculation. So that is
7.7
7.7 times
68,
minus.
350.
Okay? So the average expected weight of an average person whose height is 68 is 173.6. Okay? So then I was able to predict the expected weight or the average expected weight of someone knowing how tall they were. Okay, that's why the equation is interesting. And okay, and then again, that's why we do the analysis, because we want to be able to, given a point that we may or may not know, estimate what the expected other number is. Make sense? Okay? And then there is another useful number here, which is if I stay on the line and I look at, when I have another p-value, this p-value is very small, which means that line is pretty good. And then we have a thing called the R-square, so this is 85%, so 0.85. That number means that 85% of the height is explained, sorry, 85% of the weight is explained by the height. Okay? On average. In real life, the weight is explained by a lot more things per person. Okay? But once you have enough people together, you're going to see the taller person has more weight, as you were predicting before. Make sense? Yes? Okay. So if this was not a line, then we will try to fit them differently. And if this was too spread around, which means it will have a very big standard deviation, then we can't predict. Okay? So that's why we like things to be normal, because if these points are not close together, then I don't have anything to fit. That's what happens, for example, when you try to predict the stock market. The points are not close together enough. So it could basically be anything. So this is the same problem. You want the points to be close so that the shape that you're using to predict them is as close to the points as possible.
Marcelo, so if the standard deviation was really big, the points would be far from that line? Is that-
Correct, yes. The points will be all over the place. The fact that the points are close here is another view of the histogram. Make sense? Okay, so then that's what you do data analysis for, and then in the future, for example, you may want to use this equation to predict the behavior of some people over here, some people over there, some people in between, and then you know that it's going to be not perfect, but decently close to the number that you are looking for. Okay? And so this one, this way to calculate the line is called a regression analysis. So again, a very well-known method. The previous one was called a t-test, a very well-known method. And then the percentiles and the quartiles help you answer the more easy question that we did at the beginning. Cool, okay, so that is data analysis in 55 minutes. So does anyone have any questions? Yes.
Oh, I was just gonna say, what was the t-test used to measure again?
What does the t-test do?
Yeah.
It compares the means of two populations. So two samples,
Okay.
compare the means. or the average.
And what kind of output is it giving?
The t-test gives you, every test gives you a p-value, which is this, right? Which tells you whether you're correct or incorrect. And then you get the mean for free, but the most important thing is this. The p-value which tells you whether you're right or wrong in your hypothesis.
So a low p-value,
It's good.
sweet.
Cool, awesome, it looks like everybody used to go to class, so feel free, go around, go, and hope to see you in the future.